Profiling. Profiling is very simple. All we have to do is know the depth that we need to go. So let's go ahead and start. So I'm going to hit ZDC. So analyze, distance, center. You'll get used to that. Now you will also get used to clicking on stuff and wondering why it's not working when your masking is on. So make sure to turn that off. We're going to analyze. Again, we're going down 1 inch. So we're going to go to NC 2-axis contour. Towards the right you'll see material. We are going to click it and then double click your material box. So that's the reason we actually drew that in. And then we're going to go to part, and then we're going to go to the bottom. Now this is very important where you click, because this is going to be where your tool arcs on. So if I click the back left, it's going to arc on in the back left. If I click the back right, my tool will arc on back here. If I do the front, it'll arc on towards the front. So you have to keep this in mind, because whenever you have hard jaw in the back and a soft jaw in the front, if your material the next time you ordered it grew, or you ordered it differently and it would be more this way, if your tool is arcing on the front jaw, it would plunge into material. So you always want to at least get in the habit of double clicking on the back side against your hard jaw. Again, and that's just in case if you order the material a different size. Alright, then all we have to do is hit done. We're going to program it with a 1/2 inch end mill. Now it has all the different flutes in there, but that's not really necessary if you know the feeds and speeds that you want to go. All that's doing is calculating into the formula of giving you the spindle speed and feed rate. We're going to say tool number 3. We're going to go down to spindle speed. We're going to say 7500 on roughing. Feed rate, we can go 50 for now. Plunge rate, I always program my plunge rate at 100, and I'll explain that a little later. Whenever you first start programming, you're going to be a little scared to plunge down feeding 100, so you might want to plunge at 20 until you're a little bit more confident. But don't get stuck in that habit of always plunging at 20 or 10 or anything like that, because if you're plunging in air, then it doesn't matter. If you know your math is right, you know your setup is right, and you're confident, then by all means plunge at 100. And I will show you guys while we're running this where and how it's plunging at 100. Comments, we're going to say 1/2 inch end mill. You can call this whatever you want: 1/2 inch aluminum rougher, 1/2 inch Verimill. It just depends on what you're going to use. We're going to hit OK, and we're not going to rough with carbide. On aluminum, we're going to rough with high speed steel. More than likely it'll just be coated high speed with serrated edges. We'll go over that during the setup of the pull table. Alright, that should cover this entire front. So you want to select your tool. You can select your material. I've used it before and it really doesn't help me a lot. You can eventually create your own library of feeds and speeds. For now, I would say just stick with these feeds and speeds, and then you'll kind of learn it as you go. So the main things that you're going to have to change is the tool number, length offset, diameter offset. Skip the rest of this stuff. Go down to spindle speed, feed rate, plunge rate, and your comments. Everything I just told you is very important because that's what posts out. We're going to go to cut control. And you also want to keep an eye on this tool diameter as well, which if you select your tool, you should be fine. Cut control, we're going to climb cut. You can change your curve tolerance if you have a more accurate hole that you're end milling. For now, we can just leave it at 2/10. Alright, so let's start right here, the amount to remove. For now, which I will explain here in a minute, we're going to go ahead and just put 1 inch. And this column right here represents your sides. So let me move this out of the way. This represents all the meat that's on the side, so your X and Y. The column on the right represents everything on your depth. the amount to remove is 1 inch, and the amount to remove in Z will be 1 inch. Alright, rough spacing. So if I want to take this part and rough it in 10 steps, so I step down 10 separate times, I would take 1 inch divided by 10 and type it right here. But if I want to take it in one full cut, I'm just going to say 1 inch. Now you can do math right here as well. So if I wanted to do the 1 inch divided by 10, you just say 1 divided by 10 and hit tab, and it will do the math automatically for you. But we want to take it in one full cut. Finish passes. We don't want any finish passes because we're roughing. And same with finish spacing. Stock to leave. We want to leave stock on X and Y, but we do not want to leave stock on Z. So we'll say 8 thou stock, and that just allows material for your finish passes. As amount to remove, we can rough space, we can side mill at least 50 thou at a time, if not more. I mean, it is aluminum, we can rough a lot faster, but I'm trying to show you for now. Amount to remove, so I'm saying that there's 1 inch of material, which there's not, but we also selected this bounding box. So you could put 5 inches, you could put 8 inches, you could put basically anything you want as long as it's bigger than the distance from this edge to the edge of your material. So if that's just 200 thou, as long as we have 300 thou there, we're fine. Rough spacing is how much it's side milling at a time. So if we had 5 inches and we didn't have this material box and we just said NC 2-axis contour and we just selected the profile, we are telling Surfcam that there is 5 inches of material per side that it has to machine off, and that we're going to side mill 50 thou at a time at a 1 inch depth. Finish passes, we don't have to have any finish passes or spacing, but we do want to leave 8 thou stock. Our lead in move, we want to do an arc on. Now this is very, very, very important, this next part that I'm about to tell you. I hate how they automatically have it on plunge, but always and forever, for the rest of your life, put it on feed rate. Because what's going to happen is when your arc on starts to arc, it's going to go at your plunge rate. So when you get in that habit of plunging at 100, your arc is going to arc on at 100. So all it's going to do is drop the tool in there, arc on at 100, and then start feeding. So therefore, you end up with a broken end mill because it'll drop down, arc on, and break your tool. So always, always, always stick it in your brain to change this to feed. I cannot stress that enough. I've had people break tools left and right because of that. We are going to change this radius to 50 thou. Actually, let's go ahead and change it to 200. We're out in the air. And change it to constant. Cutter radius is a percentage. Constant is an exact number. That's why I like using constant. So it will exactly do a 200 thou arc. And you can leave the angle at 90 degrees. And I put the same lead out as I do as a lead in. That should cover this page. We can go over enable ramping and high-speed machining later. You might want to cut that out. Now for material. If you're using a material bounding box, this next part is very important. A lot of people will use the material selection and part selection but forget this step, and they'll wonder why it doesn't look right. You want to go beyond material, and you can leave it at its current settings. And this last page you do not have to worry about. So that covers how to profile your part. So let's hit OK. And you want to click on the outside, so select the side to contour. Hit accept. And let's look at it. And if you notice, what it's doing is it's cutting off the corners first, and then it's going to start profiling it. So that is Surfcam's material part selection feature.